So, hello and welcome to a new video. The aim of today's video is to solve this particular differential equation, which is a first order linear differential equation and a homogeneous differential equation as well, because we basically have no non-homogeneous term on the right hand side of the differential equation. So solving this differential equation basically means that we are going to look for the solution for the function y of x that verifies this particular equation 1 here. And in addition, we have a initial value problem. So we have to construct the solution in order to obtain y of x equals 3/2 equals 2. So what we are going to do as a start is to rewrite equation 1 under the form. So we have an equivalence basically, and we have the derivative of the function y with respect to x equals minus the function y divided by the variable x. So this particular equation can then basically be rewritten in the following form. So still we have an equivalence here, and what we have is on the left hand side we have the differential dy over y equals minus, so the minus sign of course has to be preserved, and so we can rewrite the right hand side of the differential equation in the form d of x over x. So from this basically the problem of solving this differential equation reduces to solving two integrals, because we can apply the integration here on both sides, and then we know that from calculus that this particular integral just reduces to the natural logarithm. So natural logarithm of y equals to minus natural logarithm of x. And so what we have to put here in addition is a constraint, because the logarithm actually is a function that only exists for positive x. So basically it has something like, it goes like this. So for x, and here we have f of x, the function of x equal ln x. So it only exists for positive variables, so for positive x variables, and of course we have to put a constant of integration, and so we put the additional constraint here, so x belongs to r plus. So from this we can then go and apply the exponential function on both sides of the equation, and then basically we obtain here on the left hand side we isolate y, and on the right hand side we obtain something like exponential of minus ln x minus, because basically what we forgot here is to put a parenthesis, minus k. So down there is another property where we know that minus ln x equals ln of 1 over x, or ln of x minus 1. So basically the minus goes from here to here, which is equivalent to this expression. So what we obtain here is y equals 1 over x times e to the power minus k. And this expression here is nothing else than another constant, which we will then call c. So we define this expression here, which is a constant, by another constant, which we call c. So finally we obtain a constant divided by x. Now what we have to do is to look at the initial value problem, and we have to incorporate in some way this initial value problem. So we know that for x equals 3/2 we have to obtain 2 for the function y of x that we were looking for. So basically here we can then use our solution and plug in the value 3/2 for the variable x. So 2 from 2, basically we obtain that y of 3/2 equals the constant c, and then we have to put for the value, the x value, the 3/2. So we have 3/2, which is equivalent to 2 times the constant over 3. And we also know that from 2 that this is equal to 2. So the 2 vanish on both sides, and what we obtain finally for the constant c is 3. So taking into account condition 1, equation 1, and the initial value condition 2, we finally obtain as a solution the function y, which is a function of x, of course, that we were looking for, equals 3 over x. So this is basically the solution that we were looking for. So this concludes the video. If you have additional questions or comments, please leave a comment in the message section below the video. Like my video and subscribe to my channel, and see you next time.